All right, hello and welcome to our Presto Summit series, the Zuora edition, as I'm going to call it today. I'm pleased to have Henning join me today. He's going to talk about Presto as a query layer in a distributed microservices architecture in this webinar. My name is Manfred Moser. I'm working as a community advocate and engineer at Starburst, do a lot of the documentation and outreach, and hopefully I'll be getting a lot of questions from you today in this webinar. Henning is going to talk to us and show us a lot of things on what he's doing with Presto, our beloved query engine. Make sure you throw your questions my way. I'm sure there's going to be lots of things coming up that will be interesting to everyone. So we will have the questions accumulated over the course of the meeting. You should see this questions input box on the right-hand side or wherever your GoToWebinar thing is. So just feel free to send those questions, share them around, and then we'll have a sort of batch discussion at the end. You'll see there'll be lots of things that Henning will talk about. Overall, don't forget, in this series of webinars for the Presto Summit, we already had a session about the state of Presto, where Dane, David, and Martin talked about where the Presto project is and all the exciting things that are coming up. And that is on our website, PrestoSQL.io, where you can find sort of the overview of that and the recording. So make sure you go back and watch that as well. Obviously, you can't ask questions, but maybe you can bring them for next time. We'll have lots of more virtual events going on. And of course, if you haven't grabbed a copy of the book I wrote together with Matt and Martin, Presto Definitive Guide, make sure you go to our website, starburstdata.com, where you can get a free copy of that book and hopefully find lots of mistakes in the book that I made so that you can send the errata to me and I can improve our beloved frog book for the next edition as well. And with that, I'm going to hand it over to Henning to talk to us about his uses of the Presto query engine at Zuora.
All right, thank you so much, Manfred. And thank you to Starburst to give me the opportunity to talk here about the use of Presto at Zuora and how we use it as a distributed as a query layer in our distributed microservice architecture. Short disclaimer, everything you're gonna hear in this presentation is subject of change, obviously. Please don't make decisions based on the content of this presentation only. Feel free to reach out to Zuora if you have questions about it, but we take no responsibility if what we talk about here is not going to come to fruition. A few words about Zuora. We are the company behind the subscription economy. We are a subscription billing system. We offer this as software as a service to our customers, so we are a cloud-only company. We've been around since 2007, so we've been around for a while. We have about 1,200 employees worldwide. About a third of that is part of the technology organization that I'm a member of. We are a pure B2B company, so we have no B2C offering. We have more than 1,000 customers worldwide, and we're a public company. We're listed at the New York Stock Exchange, so our revenue numbers and our quarterly invoice volume are public information, and they're here for your information. A few words about us. We have a wide variety of customers, from almost a fifth of the Fortune 100, 7 of the 10 top auto manufacturers in the world. We have major newspaper publishing groups as our customers, and especially we have a large number of organizations that provide services as subscription services in high tech. We talk publicly about some of them. I mean, the company everyone knows these days of Corona is Zoom, is one of our customers. GitHub is one of our customers, and Fender is selling subscriptions to their musical instruments and their musical services through us. So we have a wide variety of customers that sell all types of subscription services, and they use us to manage their subscriptions. A few words about myself. I joined Zuora in 2015, so about 5 years ago. And I serve as the chief architect responsible for the technical direction within the organization. I'm an alumni of large B2C organizations like Groupon and Facebook, and I worked at startups in the Valley. I've been involved with open source for a very long time. Manfred called me an old hand, but I've been engaged with the Apache Software Foundation. I'm a member since 2004, and I served on the Apache board for 2 terms. So open source is very dear to my heart. It's something that is really, really important. And I think the success of our industry is very much dependent and relied on open source software. So first I want to talk about why did we build this system based on Presto? And technology is never something that you just build for yourself. You don't just choose one day that, oh, I really want to have Presto in my ecosystem. But you use this as an enabler. You want to understand the problem that you're trying to solve. And then from the problem, you work towards the solution. And for us, Presto turned out to be the right solution for the problem that we had. So as I said earlier, I joined Zuora in 2015. And a part of my responsibilities, why I joined the organization and took on that challenge, was that at that time, Zuora was a very proper monolith. So we had a big monolithic code base that literally compiled into one giant service. And we had all our data in one big database. And the goal was to move this technology architecture forward, to get away from the monolith, which has its own challenges in terms of service delivery, in terms of scaling and reliability, to a modern distributed architecture where you have this large number of loosely coupled services. And that's not an uncommon story in the industry. It is something that a lot of organizations go through. And Randy Sharp called it, you get the opportunity to do that. A lot of organizations never get this opportunity. And so we really embraced that opportunity to move to this new architecture. And if you read about the success stories that you see in the industry and you look a little closer to them, they're actually most of the time talk about the transition of the services. They talk about how to break up the code base, how to turn your large monolithic service into many services, but they almost always neglect the data. You look at those stories and they often conclude with, and we left all the data in the one big database because that served us well. So this pattern of service-based architecture, but data monolith is pretty common. That is something that wouldn't work for Zuora because the growth of data, especially in our system, which is a multi-tenant system, had become an issue. So we very early on took on the challenge to breaking up both the service architecture and the data. And the data monolith is what I want to focus on when I talk about our distributed query engine for which we then use Presto. So why is that different? I don't want to say one is better than the other, but these two systems, they have very distinct properties. If you have a monolithic database, it is useful because you have all your data in one place. And even though that sounds challenging first, it actually, for a company like us, like Zuora, we can shard the data very easily. As I mentioned before, we have a multi-tenant system. So data for each of our customers is organized in what we call a tenant. And of course, these tenants are very strictly separated. You never ever want to have a customer access data of another customer. So this separation in tenants is a very easy way to shard your data. And even though we say we have one database, we don't have just one database server. We have many database servers, and each of those servers holds data for a subset of our customers. This can range from a single customer for a very large customer, all the way to many customers on a single shard. So actually, this data in one location worked out for us basically well till about 2015. Transactions are easy. That is something for a financial system that is really important. You want to have transactional consistency. You can leverage the database to query. So a lot of the times you actually want to fetch data from the system, you just go straight to the database. And then you can use all the tools that the database brings to copy the data, to clone it. You could just take the files from the file system, move them to another machine, and you have a bitwise copy of the customer data. And you just have a single technology to focus on, which for a small company, if you're starting out, is a good thing, because you don't have to invest in many data store technologies, but only in a single one. On the other hand, a distributed system has advantages for a fast-growing company like Zuora. You can isolate the data stores for every service, and you get rid of all those limits where you end up a database instance has a maximum size, or a shard has a maximum size, because you now have the data separated and you can scale it very differently. And the other thing you can do in that world is you can use best of breed technologies. If you need a graph database, you can use a graph database. If you need a relational database, you can use a relational database, and a document database. So you're not just limited to the one big monolithic database that is basically the lowest common denominator. And then ultimately you can scale your services very differently. And when we looked at the different properties of these systems, we decided that while the monolith has served us well, our goal was to move to this distributed data system that you see on the right. So we had a very similar thing to the famous Bezos mandate within the organization. And between many other things, the Bezos mandate, which is this legendary memo that Jeff Bezos wrote to the Amazon organization, it says, data is owned by a service. You can access the data only through APIs. There are no backdoors. You're not allowed to go around the service that manages the data. And that is a goal that we wanted to accomplish within the organization, because it allowed our teams to be autonomous and to develop their services quickly and without having to continuously synchronize with all the other teams. However, by doing that, some of the operations that we used all over the monolith, they suddenly became much more challenging. If you wanted to take two pieces of information that were in the monolithic database, you could just join them in the database. Once they live in different services and you cannot access the database directly anymore, you have to do this through the service APIs, which means you have to write code to fetch the data, to run the join operations and all of that. And that obviously is overhead that we didn't have before. Same applies to loading and managing the data. And ultimately, you also want to have a consistent view of the data. Our challenge, where we leverage Presto to solve, is around the join operations. And that is what I'm going to talk about in the next part of the presentation. And that is, what did we build and how did we leverage Presto to make it possible for our customers to still access the data, even though we changed our internal architecture completely. So a few words about how customers access data on Zuora. As I mentioned, we're a cloud service. So all the data doesn't live on-prem, it all lives within our own systems. And customers access their data that they store on Zuora through our APIs, and they use a concept which we call a business object. A business object is a structured piece of data that has defined attributes that can be extended by customers with their own attributes. And they represent all the different financial concepts that we have in our systems, like an account or a product or customer information or a subscription. All of those are structured as a business object. And ever since Zuora started as a business, we exposed the information using a query language, which is called ZOQL, Z-O-Q-L, Zuora Object Query Language. We as an organization, we have a strong affinity to the Salesforce ecosystem, and Salesforce has a very similar query language, so we got one too. What this language allows our customers to do is to fetch information from our system with a vaguely SQL-like syntax. At the bottom of this slide, you see one of the queries, how you would send it into Zuora, for example, to select all the account numbers from the set of your accounts where the customer has not activated autopay. The power of this query language is that it actually allows to join the different business objects that we have on Zuora. We have about 80. The interesting thing that we found out when we analyzed the data on how our customers use our system is that the vast majority of all queries that customers run against Zuora return a very, very small result set. More than 90% of all the queries that customers run using SQL return either 0 or 1 rows. So we're not talking about big data, we're talking about very small data here. The execution of a SQL query is usually few seconds to low minutes. However, we have outliers both in result size and performance within our system. We have queries that customers run on a regular basis that return hundreds of thousands to millions of rows. And also we have queries that run for hours. We do cap some of these things, but in general, customers expect that they can run both these small queries very quickly, and then they can run higher volume queries and they still execute successfully. So the way we built this in the monolith was actually very simple because we had a database. So SQL was implemented as a layer on top of our data monolith. When you ran a SQL query against our system, it was transformed into a SQL query. All of the database-like operations that the query language offers, like joins, aggregations, predicates, all of that, we literally gave them to the database and say, hey, you take care of this. And then we send the resulting data back to the customer as the output of the API calls. Something that was important for us and that influenced the way we build our new query system was that the data stored in the database has a significantly different shape from the data that the customers see as business objects. As many systems that were started in the early 2000s, we heavily normalized the data in the database. Something we wouldn't do again today, but that's the data we live with. Some of the data was structured in multiple tables, even though they are represented as a single object. So there is actually quite a bit of transformation going on of the queries sent into the database and then also send the data back. And that was something we had to keep alive when we moved to this new distributed world. Because once we have no longer a data monolith, things that were easy before are suddenly no longer easy. Our business objects are now managed by many services. And they even use different data store technologies. What used to be stored in a relational database may now live in a document database or a NoSQL database. So we cannot express these relationships that the SQL query needs as a SQL query, as a SQL join in a single database. And at that point, we had to change the way we allow customers access to our data. However, very often when we talk about these problems at Zuora, people come up with the obvious solution. They say, why don't you replicate to a data warehouse and use that? And so the challenges that we're facing, even though they look superficially like what other organizations have, they're actually not. They're very different from what other organizations have. Many organizations do not actually distribute the data across multiple stores. As I said, they just keep living with the data monolith because it serves their needs. It scales well enough for other organizations. That is something we couldn't do at Zuora because we ran against the limits of the data monolith, like the single database size. Many organizations have only a single set of live data. So if I'm running an e-commerce site or if I'm running a social network, I have one set of data. We don't have that at Zuora. We're a multi-tenant system. We have thousands of customers, and each of them has their own set of live data, and this data has very different properties. We have customers that have not many accounts, but many subscriptions. We have customers that have many accounts and then only a few subscriptions per account, and everything in between. So the live data sets that our customers use are very, very different. Most organizations then, when they have a set of live data, they know exactly what queries you run against that data. We don't. We have APIs where customers can send in the queries that they need, and we want to execute them on our system. We can't code these queries specifically. We can't just write Java code or any other technology code to execute these queries against the data APIs, because customers have all these different query needs. So we have to have a way, which we had with SQL initially, to express those queries that customers want to send in. And the data warehouse solution didn't work for us because the customers expect those queries to go against the live data. When we replicate the data into data warehouse, you get a certain amount of delay. And we evaluated that with our customers, and even a small delay like 30 minutes to an hour was not acceptable to a large set of our customers. So our customers expect us to offer them APIs to run arbitrary queries against their live data in a multi-tenant system. And that puts us in a quadrant where solutions are scarce and you cannot take anything off the shelf right away. So we sat down, and when we outlined this data query project, we came up with a number of success criteria that we really wanted to have to make this feasible. First of all, when we split the data up, we want to be able to keep accessing it as before. And whenever new data sets come up, we have now a revenue solution. We want to have the data accessible as it becomes available. And it also should be access to the live data, not replicated data. We settled on SQL as a query language very early because we felt that SQL in many places was limiting our ability to run queries against the data. We wanted to be in the same ballpark with the performance as we were with the monolithic database. And something that I can't stress enough, and that is part of the success of our project, we wanted to have immediate customer value. This type of project lends itself to, oh, we spend a year of building infrastructure. We think this all the way through, and then we start building this, and a year goes by, and you haven't demonstrated any value. Our goal was to have immediate customer value within a few weeks of the project starting. Obviously not for all customers on day one, but for a subset, and then go from there and put this into a feature that every customer can use. And I think a lot of the focus and the success of the project came from that. Internally, we fully understood that our teams were all busy transitioning from that monolith to the distributed architecture. So we wanted to minimize the burden of implementation for the teams. If the query project shows up and says, now you need to spend another 3 months implementing this really complicated piece of technology, the services would not have been as receptive as they were when we said, here's a minimal way of implementing this, and then you are on board with this new system. And one decision that we made very early on is that we didn't want to touch the legacy code base. We wanted to go against the data, but we wanted to bypass the existing service code base in the monolith. So we settled on building new APIs and a new UI for customers. So every new customer can integrate right away. Existing customers could migrate to this solution, or when they expand their integration with us, they could leverage this. The existing query system we kept around, and it's still around, but obviously all new features are no longer showing up in the old system. We put backwards compatibility and then full SQL compatibility on our roadmap. And I'm going to talk about the roadmap in a bit. So how did Presto help us here? And I call this Presto to the rescue because we designed 6 different options. We prototyped 2, and the one where we leveraged Presto really stood out both in terms of flexibility and performance. And Presto has a number of really nice properties that helped us to get comfortable with it and adopt it within Zuora very quickly. It has this very open architecture, the plugin architecture that allowed us to easily customize the code base, to customize the way we use it within Zuora. It uses industry standards with SQL as a standard query language, and not just a subset of SQL or this is almost ANSI SQL, but the following features are missing, but full ANSI SQL without compromises. It is known to scale really well. so all the way to exabytes. So we were fairly certain that for our use case it would work, and if we had to scale up, this would work well for us as well. It comes with a commercial friendly license as an open source project. While we are doing software as a service, so we're not actually shipping software to customers, having an Apache license project with its patent guarantees and all the different integrations that are based on Apache licensing made our lawyers comfortable and made us as an organization comfortable. And then ultimately there is this vibrant and very active user community that we want to be a part of and that we want to contribute back. So when we looked at the different query engines, we ultimately settled on Presto as the solution that we wanted to go with. And this is the 50,000-foot view of what we've built and what is the backbone of our project data query. Presto sits in the middle as the engine that takes all these queries in, that then fetches the data, puts it into a relationship, and ultimately sends the data back to the customers. We built a custom connector, and I'm going to talk about this connector in a little bit. What's more important for us is we looked at all the different data services, at our old monolithic database, at all the new services that we were building and where we were moving data into, and we defined an abstraction between the services and all the query engines, of which the Presto engine was the first one we built, and we defined this common data rail. So there is a client library, which we call an SPI, that services integrate with, and then there's a client library that can access all the services. You cannot just ship something like Presto to customers. What you have to do is you have to build infrastructure around it. So on top of this, we have what we call our query controller, which is just another microservice. And that ultimately then has all the customer-facing APIs where customers submit queries to the system. And on top of the API, we have a UI layer, which allows customers to do their queries interactively through a browser. So we started with 0.194 in early 2018. We went through various versions of the Presto engine. We went to production with version 3.02, so we transitioned from PrestoDB to PrestoSQL. We're maintaining a small patch within our system because we moved some information in the session around. We offered the patch back to the community, and we're still going back and forth whether it's the right thing to do or not. But we ultimately just maintain this small patch, and it's very portable. So that is not a big deal for us. As I said, we built a custom connector that integrates with our service SPIs. And we maintain a set of custom functions that we use internally to convert data between the representation in the services and the representations that customers see. Everything else is using the standard APIs. So we plug into the listener infrastructure, we talk JDBC to the Presto clusters. We chose to do minimal modification to the Presto engine so that it fits our needs, because we are a small engineering organization. We don't have dozens and dozens of engineers that allow us to maintain our own fork of Presto. We wanted to stay as close to the mainline as we can, and we wanted to leverage as much standard software as we could. So our plugin exposes all our business objects as tables for customers. So when you go to data query, you see all your business objects as tables within Presto. Every tenant has its own set of metadata. So this is different from how you would build this for a system with a single live data set, because our tenants can modify the business objects. They can add attributes. So for every customer, the metadata is slightly different. So we have to maintain completely separate metadata for all the tenants. One thing we very early on did is we resisted the temptation of mapping every tenant onto its own schema. We wanted to ensure that it's impossible for one tenant to access data of another tenant, which once you map the data onto schemas, then relies onto just permission setting. We actually built a mechanism that uses session data to ensure that only the tables are visible for the tenant that has actually authenticated with the system. So if you're tenant A, data for tenant B is not accessible to you ever, and it's impossible for you to get that. We built something that customers, well, let's say it's a little bit of controversial, but we put strict limits into the system. We limit the number of rows that you can fetch from any of our live services to 1 million. And we also limited the number of output rows of any query to 100,000. The reason for that is that we need to protect the live system. Remember, the query engine, when you run a query against it, will actually talk directly to the data services. So it will basically use our internal APIs to fetch data from the live system databases. And Presto, powerful beast that it is, you can very easily brown out all your services by run this unchecked. And we had to put limits in place to ensure that the service quality through all the other APIs and all the other things that we give to customers is not affected by running these queries through Presto. One thing that really helped us was defining this SPI, where we abstract the differences between the services. Every service can take this SPI, and we are still very much a one technology Java shop. So we have built this in Java. You take this SPI, you integrate it with your service very easily. The easiest integration is just implementing a single interface, and you're on board with data query. And then there are various layers that you can add to this to improve the performance of your service on data query. The most important thing is predicate pushdown. Without predicate pushdown, you basically have to do a full data scan every single time, and that's not acceptable for the large data tables. So predicate pushdown is basically a must for every service to implement. We defined a common internal metadata format across all of our services so that the tables look uniform. We move the data between our data services and Presto as compressed JSON. We experimented with Smile as well, but compressed JSON ultimately has about the same performance characteristics, and it's more compatible because JSON is more common across technology than Smile, which is still very much a Java thing. We started just sending data streams that turned out to be brittle. So we built a pagination-based protocol between our data services and the query engine, which turned out to be a good decision. At this point, it's a very robust way of moving data across our ecosystem into the Presto engine. One thing that we would have loved to overcome, but we couldn't, is that for every data connection between the query engine and the data services, we only have a single split. Because we talk to the APIs, and service APIs are almost never designed to do parallel data transfer, we have a single data stream for every data object that participates in a query. So the connector just receives a single split from the data service, and then there's one data stream for every business object that's involved in a data query. That is a performance limitation. It's something that we want to look into in the future, but right now that's just what we're using, and it's working well enough for us. The most important thing for customers is that we put this query service on top of it, which manages queuing of queries, how many queries we execute in parallel, how long a query can run within the cluster to ensure that the cluster doesn't overload, and we have a SLA that we can offer to customers, and they understand how they can submit query to our systems, and they don't step on each other's toes. So I talked about the goals that we had, and the goals for our customers, we basically accomplished. Customers love this feature. They love this so much that they don't even care about SQL and backwards compatibility. We ask our customers, and they all love SQL and the new APIs. No one actually wanted SQL back. So we struck it from our roadmap, and we're focusing on building more value on the existing system and not so much trying to adhere to backwards compatibility. The vast majority of our existing customers adopted this feature within weeks, which is something that we were very excited when we shipped this as GA a few months ago. And it's one of the big hits with our customers. So today at Zuora, we run more than 100,000 queries every day as part of our customer integrations. So customers fetch their business data from our system through Presto. We have 75% of our customer base that have integrated, and hundreds of our customers are daily active. Remember, we're a B2B. We don't have millions of customers, we have thousands of customers. So many hundreds for us is a huge success. The typical table that customers query holds about 1.5 million rows. Again, if I look at the data warehouses that some organizations run where you have these billions and trillions of rows, it looks small, but this is live data. This is data customers modify continuously. And the average query that the customer run today returns about 1,000 records. That surprised us, given that the initial data said, oh, most queries return 0 or 1 records. So customers on average run much more complex queries against the system than they did against the old query system. That is something that we found interesting and something that we're digging into more, because it changes a little bit the focus of what we expect customers to do. What's next for us? We're upgrading to the current Presto, which is 336 for us. I know 337 just came out, but to quote Manfred, there's always a next version, and 336 is our next goal. This also means we're going to switch to Java 11. The current version of Presto that we run, 302, is running on Java 8, and we're excited about 11 because of the performance improvements that it brings. We want to move to multi-cluster. The query service that we built helps us isolate the customers from Presto when we have to do maintenance and when we have to do upgrades or failover between our clusters. Multi-cluster will help us to do seamless failover and to either move to an active-active or active standby configuration. Like most organizations, we have a big push to Kubernetes internally to run our services. We're currently running on ECS, and it served us really, really well. But having a uniform service architecture that runs on Kubernetes and then leverage all the features of Kubernetes to scale the clusters up and down is something that really, really excites us. And then we always are in search of more performance for our customers. Aggregation pushdown is something that I'm really, really excited about, because it would alleviate some of the pain points that customers have today, where, for example, count operations that were relatively fast on the old query because they were pushed to the database are not as fast anymore in the new data query system. But with aggregation pushdown, we can get the performance back and also limit pushdown. And then we also have acknowledged that customers want to run these large analytics queries. And we talked to those customers and they said, you know, for those queries, we don't really care about the life. We care more about not having the limitations. So we are working on a new backend that will allow these large queries to be run successfully against slightly delayed data. And that is something that we will hopefully ship very soon. And with that, I'd like to say thank you to Starburst and thank you to all of you listening. And I'll hand it back to Manfred. And of course, we're hiring at Zuora. If you're excited about the subscription economy and excited about the technology that we're using, I'll encourage you to check out our career site at Zuora.com about careers. All right, thank you so much, Manfred, for Q&A.
Thank you. Wow, that is amazing, Henning. I'm impressed. I have to say that's amazing what you're offering to your customers. And it's not just me that is amazed of what you're doing. There's a whole bunch of interesting questions, ranging from topics that were raised in the beginning to like really detailed lower level questions. So I think I'm just going to go through some of them. The first thing that seems to always come up, and it came up here as well, is you talked about the monolith and how you ended up having to abandon the monolith, right? Like, you know, like, I don't know, like Facebook ended up dying with like whatever they were using, PHP, and then Twitter with Rails. What was your monolith, and what was the breaking point where you're like, this is just not working anymore? So if you can divulge a little bit into that.
We've talked about this before. So as I alluded to earlier, Zuora is a proper Java shop. So our monolith was a early 2000s vintage Java monolith, and it was built exactly the way you would build it back then, based on Spring Framework, Hibernate, and struts. And we realized, and listen, the monolith served us really, really well. It is not that you look at this back and say, how could we? But if you want to start a business, and if you want to start at some point, and you want to focus on delivering value, the monolith is a good choice. The important thing is to understand that at some point your business has grown so far, and you want to be able to deliver features and innovation so quickly that the monolith, where all the teams' work flows together, it all has to be integrated in one place. It becomes a hindrance. So you either have to continuously invest in infrastructure to ensure that the work of the teams can all flow into one place with high confidence, which is, by the way, what Facebook did. UI in Facebook is still a monolith. It's a large thing, but they've built so much infrastructure around it that as the individual developer, you can do this. And in Zuora, we made the decision that, first of all, we want to open up the different technologies. And we had scaling issues. We had the need to ship certain features differently. We wanted to integrate with other technologies. We wanted to be able to, for example, integrate new UI technology. And for that, at some point, you have to look at what you have and say, okay, how do we accomplish this? And for us as Zuora, the decision was, we want to transition away from having all of our eggs in one basket, and we want to be able to give the teams more autonomy. And we accomplished that by starting to build these services and integrate. Let's be clear, the monolith isn't gone. It's still there. And most organizations that start out with that, they end up with the monolith being a remnant in the corner, and that still does some of the work where you look at it and say, that's probably diminishing returns to keep refactoring that part. And it works okay, let's just leave it. And we are moving in that direction as well.
Yeah, very interesting. It's funny how people always badger on a monolith being a bad idea. I always kind of think of it like it's just really a different perspective, right? Like a monolith is like, you think of the big mess being inside it. And if you have like a very complex multi-services and whatever architecture, you just look at the individual pieces as if you are in the monolith. But really, both systems can be very complex. It's not like you're trading complexity. You're just looking at it in a different way to some degree. But yeah, it's a good stack. So another question that came up was all about your infrastructure of the data rail and the SPIs there, and sort of like how you're managing this. So what happens with, like, say, schema migrations or whatever is actually what is underneath the hood in these different services that the SPIs basically expose? Like, are there relational databases underneath, or like all sorts of different things, or is it completely transparent and you don't really care and each team does whatever they want?
So it's a little bit of the latter. The idea of the SPI is that we expose the data in the shape that the customer sees. So when you fetch an account business object or subscription business object in the shape that the customer expects, that is the data that flows through that data rail. So the service and that integrate the SPI, they have to take the internal representation, turn it into the customer-facing business object representation. That's the metadata that the service exposes, and then send that data through that data rail. How they store it internally, how they manage it. We have services that use MySQL. We have services that use DynamoDB. We have all different ways of storing the data internally, and that was the intent was to abstract that away. Give the team freedom here, but also there is a clear specification on how they have to expose the data to this query engine, because otherwise the team that manages the engine, they have to basically adhere to every single data change in the services, and that is not scalable. So
yeah, you'd have to have tons of different catalogs files for all these different things and support all these different connectors, right?
Yes. And the data rail is the point where the query engine and the data services meet.
So how do you then tune your Presto? That's a question that came up from William as well. Like from what I understood, you're running basically one rather large Presto cluster. How do you tune that, given that you have the one connector, that's your SPI connector, but ultimately the behavior or performance of that connector will kind of like depend on the performance it gets out of each individual SPI implementation it hits, right?
Yes. So and all my coworkers that listen to this, they will roll their eyes because they heard me say that so many times. You live and die with your I/O performance. Given that
Yes.
everything in Presto streams through, you can tune the system so that the performance of getting the data off disk, that is the performance that ultimately the customers see. So we haven't tuned Presto that much. It comes really well tuned out of the box. I know we increased the size for the total memory for the queries a little bit. We do tune through the size of the cluster with the number of queries that we run in parallel and the number of customers using it. But ultimately the performance, whether a query is fast or slow, it depends on the data service. So we go back to the data service teams and say, hey, this is slow. This is what customers see. We can track this down to the performance of sending this business object into the system. Is there something you can do about this? And then we try to work all the tricks around projection to limit the data that's flowing. Predicate pushdown I already mentioned, which is crucial for performance, especially for large data sets. But yeah, it boils down to the individual data services.
And there's also a question: is compressed JSON for the data flow used for the custom SPI usage only, or do you like use that generally? Like that's, I guess it's sort of related also to that whole UI, like IO throughput. Are your data sources like in a network proximity, like closely related, so you get like good performance out of them, or do you have anything that's like a bit more remote and then problematic?
So we have our modern clusters, they are all in AWS. So everything's close to each other. It's in the same region in AWS. We obviously have failover like every other organization, but we run production from a single region. We have some legacy systems where we are half data center, half AWS. There we have a little latency that we incur between data center and AWS. But in general, yeah, everything's close to each other. The compressed JSON is something that we use internally. To customers, we actually offer different data formats. Customers love CSV for obvious reasons. You can load it into Excel. So yes, we offer other data formats. So there is the internal data that flows through our data rail, which is not accessible to customers directly. And then there is the representation that comes out of the query service, where we support more data formats.
Cool. So another question is about overall, I think like I would guess we could call it the customer experience. So on the one hand, you talked a lot about actually slowing down Presto to basically not throttle your SPIs and like totally gray out everything because it's too aggressive in trying to get everything. But you also talked about having SLAs and then your users having certain expectations on how fast queries are returning. So what's your like some of the tips you have in like how you're achieving that? You are sort of like, you know, like you're taming the wild Mustang that is Presto, so to speak.
So we're not actually slowing it down. We're just limiting the number of rows.
Okay.
So we allow the data, if the data service chooses to slow down the data that they send back to the query engine, then they can do that, again, within the SLAs that we have. But we as the query engine itself, all it does, it says, I'm gonna fetch at most 1 million rows from you. I'm not gonna fetch more. If the query that the customer sends in requires more than 1 million row, we fail the query, we explain to the customers, and then we usually work with the team on the customer side or with our own integration teams on how you can change the query so that you stay within those limits. That's the path we've chosen there. The performance itself One thing that we work closely with are actually obviously our database teams. And the database teams, they often say, well, don't do a long running query. Use shorter queries, just use many of them where you can actually fetch the data in pages from the database, because that is better load on the database than just having one really long running query. At that point, I follow the advice of my database team. I'm not really a deep expert into that. And so we encourage the data service teams who ultimately own the data to just follow that advice. And in general, it works out okay for us.
Fair enough. So on the customer side, you said you talk to your customers and teach them, or like tell them like how. So do you like basically have like well documented or like exposed schema that people can use to understand how they query their data, and example queries and whatever else? And how do they, what's their user experience? Do they just press on buttons to run queries, or do they actually type SQL? And can they save their queries to run them again? Or what's the typical usage that you get? Or is it all over the place?
So let me unpack that a little bit. Yes, we have a knowledge base in our developer center that documents that. Our business objects are obviously well documented, the shape of the objects. And one of the things that is really important to us is consistency, that the data looks the same through all APIs. The common integration for our partners is using our APIs. So how they submit the queries to us through the APIs, well, that's on every customer side, and we often don't actually know how they do this. Most of them pre-code the queries and they just send these queries in. Others may have internal query UIs. We do have a query UI on Zuora as well, which you can use to run ad hoc queries. And there you can do all the things you mentioned. You can save queries, you can fetch them back. We have customers running really, really complex queries. I learned that there's actually a limit in the length of the SQL query you can send in, which I didn't know, which is a megabyte. and the fact that there is a limit for a megabyte shows me that people try to go past that at some point, probably not at Zuora, but maybe at other organizations like Facebook. So yes, we see the customers try these things out in the UI. And my assumption is that they often try this out in the UI, and then once they settle on a query that works for them, then they bake it into their integration.
Very cool. So I think we answered all the questions from the user. So I have a question to you in general about Presto, and that is, what can we do for you to make Presto even better for you? Like, what do you wish Presto would have or would add? I mean, I noticed you were talking about the aggregation pushdown, and that's something that we are actually like quite actively working on, and that's coming slowly. So hopefully there'll be more happening. But are there any other things that you like would love to see in Presto? I know you were raving about the connectors and the basic pluggability already, so maybe we could write another plugin that helps you with something.
So first of all, I really appreciate the book. And the book gives a lot of additional information that basically was available in the source code before. If you look at the Presto source code, and I mean it's this giant beast, there's so much stuff in there that is not well documented. It could be better documented. I mean, you look at the SPI that Presto offers, and it has a wealth of functionality. And yes, while some of it is documented, and then there's example code in the example connector, that you can always discover another feature that is used in one of the connections, like that's useful to us, and it's not actually documented that well, even though it's part of the SPI. And so I think in general, you have to actually spend quite a bit of time with the source code today to really understand what you can do and how you can leverage Presto. That is a little bit of a barrier to entry to some engineers, because we have to encourage our people to just, no, you need to spend time reading that source code. And having better documentation always helps. I mean, we all know that. You write 1,000 pages of documentation, and customer shows up and says, I wish there were more. So I wish there were more. On the other hand, I think that having a clear roadmap of what's going to be shipped, what is part of Presto 6 months from now, 12 months from now, that would also help. And sometimes we just look at this and it's like, oh, something new showed up. That's useful to us. But we don't have engineering capacity to integrate this right now. If we know this is coming down the pipe 6 months from now, we would basically ensure that by the time the feature arrives, we would be there to receive it. But in general, technology-wise, Presto has served us so well. We're very grateful, and I mean, it's an amazing piece of technology, and I don't want to give Dane, David, and Martin a big head, but I mean, I'm always impressed. Every day I'm using Presto, I'm impressed with it.
Excellent. Well, it's good to see that you're putting salt in my wound, since I'm sort of like the main documenter these days. But stay tuned. There's a lot of stuff happening, and we Starbase is definitely heavily investing into improving the documentation for Presto overall. And also, I guess now I have another focus point. I'll need to improve the documentation on, like, you know, the hardcore people that actually write against the SBI and work on that. So I guess you're gonna have to pick a bit on Martin and Dane's and David's brain, because mine is not filled with that kind of stuff just yet. But it's always good to have more to do. So make sure you keep up with what's happening in the Presto project, and please do join us on the PrestoSQL Slack community. I know Henning is there, and he's probably going to be able to answer a question here or there. Don't ping him too much. I'm sure he's very busy. But myself and many others in the Presto community are all hanging out there. Go to PrestoSQL.io, the website, to find out what's coming up in the newest releases. And yes, Henning, we will try to be more transparent. But as you know, an open source project, planning an open source project is tricky, because you don't really know what contributions are going to come your way. But we are definitely in the process and having big plans ahead. And for those of you that haven't seen the state of Presto yet, again, as I mentioned earlier today, there is a recording, and Martin, Dane, and David talk very much about what's coming up and what are some of the planned features that we're working towards. And if you want to help out and go and look at the source code like Henning and his engineers, you're more than welcome, and we'd love for you to, you know, write your own build connector or look at other code. Any contributions are always welcome to the Presto project, and we'll help you along the way, so to speak. So I think, Mandy, I think we're pretty good here. There's no more questions that come in, but I think it's been great.
Thank you to you both very much, and we hope you all enjoyed this, and we'll be sending up a follow-up email in the next 24 hours.
And we'll also make sure that the recording shows up on the Presto website for those of you that missed us. And don't forget, we have more events coming in this series. So stay tuned on announcements on the Slack channel and on the website. Thanks again, Henning. It's been awesome.
Thank you for the opportunity.